All right, we'll begin by talking about tangents, which is our first topic with circles. So, what does it mean to be tangent to a circle? Now, this is kind of a different definition of tangent. It is related to sine cosine tangent, but for us, we'll treat it differently. So, it's a line that intersects a circle at only one point. Okay? And a point of tangency is that exact point where a circle and a tangent line intersect. So, for example, for this picture, we could say line AB is tangent to circle O. That's the little circle symbol at point P. Okay? And the first fact that we're going to learn about tangents is that they're perpendicular. Okay? So whenever you have a tangent, that's the same as saying that there's a right angle there. And the other way is true as well. If you have a right angle, then the radius here, this is called the radius, and the tangent line AB are, it's a tangent. So if it's tangent, it's a right angle, and if it's a right angle, it's tangent. Right? So just with this fact, we can solve some questions about missing lengths between tangents and parts of circles. So to find angle measures, we can add this to our picture so that we know that 117 plus 90 plus 90 plus x equals what? Remember that a triangle adds to 180, but if you had two triangles, you would have what's called a quadrilateral, a four-sided shape. And that's what we have here. So this adds to 360. So triangles have 180, quadrilaterals have 360. So this is going to go ahead and add up to 297 plus x, 360. So x is 63. So if it's tangent, we have a right angle here. So again, we can set up a similar thing. We have the three angles labeled. These three angles here have to add up to 180. So x is 52. So you can find angle measures by knowing that there's a right angle for that tangent. Okay. What about if you're interested in the radius and had some extra information? Well, we know the Pythagorean theorem works only for right angles. So we could set up a Pythagorean theorem here where, so the x and the 12 are the shorter sides. So it's going to be x squared plus 12 squared equals, and in this case, we have the radius x and this extra length 8. And remember, if you have a quantity squared, you write it out. You always have to expand it out and then distribute. And you've probably seen this before. I use the acronym FOIL. So this ends up being x squared plus 8x plus 8x plus 64. And you can combine those middles. Okay. So x squared plus 144 is x squared plus 6x plus 64. 16x. So we can actually cancel the x squared, which is really nice. So we get, and we can also subtract 64 from both sides. So we get 80 is 16x, so x has to be 5. And here we have the same thing. So x squared plus 10 squared is x plus 6 squared. So x squared plus 100, and then when we write this out, we would FOIL. So we get x squared plus 6x plus 6x plus 36. Okay, and then the same steps as last time. We can cancel these and then subtract 36. So we get 64 is 12x, which doesn't go in evenly, but we can still divide by 12 and get our answer, and this happens to be 16 over 3. Okay, so a little theorem for us and a little proof, so we can get, I don't know, some experience with proving stuff in circles. So this theorem is really nice. It's the intersecting tangents theorem, which says that if you have tangents like AB and CB, and if they intersect, these are equal to each other. I always call this the party hat because the red here kind of looks like a party hat on a head, the blue head, and the two sides of the party hat are congruent. That's the theorem. So how do you prove that? Well, we have a given, and we're going to start by drawing two radii from O to A and O to C, and we know that those are right angles because the problem says they're tangent. So this will just be the definition of a tangent line. And you can also draw in this line, OB. And OB, well, the reason why we're saying this is because, look, now we have two right triangles that look like they're the same. So this is a shared side. So it's congruent to itself by the reflexive property, which we've seen before. And the reason we're saying this is because now we're probably trying to match things up to show that triangles are congruent. So that's our first side. And we're talking about congruence. We're not talking about similarity anymore. So it also says that AO and CO are congruent too. Why? Well, we haven't used this reason before, but those are radii on the same circle. And all radii from the same circle are congruent. Or they have equal length, right? And that's true. I mean, that's just the definition of a radius. And all those markings are enough to show that the triangles are congruent. And that's because it's a right triangle. It has a hypotenuse and a leg. And those together make HL, hypotenuse leg theorem. It was our fifth and final way to show that triangles were congruent. And if you have triangles are congruent, all 6 of their parts just match up. So this red part and this red part are congruent because corresponding parts of congruent triangles are congruent. So actually a really, really nice proof that's difficult enough, and it also uses some stuff we used before in the class. So it's great. 2 more. So using the party hat theorem, we'll call it the party hat theorem, we can solve this question real fast. It says that a circle is inscribed here, which means all these are tangent. And that's the only requirement. And for these to intersect here. So this party hat right here, this is also 15 by the theorem. This is also 8. And this is also 10. So if you add up all 6 of those, you get your answer. Because the perimeter is the distance around the whole triangle. So it's 10 plus 10 15 plus 15, and 8 plus 8. So if you add up all those numbers, you are going to get 66 centimeters. And this one switches the question up a little bit, but still talking about the same equation. So all the party hats here are equal. We know these are equal, but we don't know what this is yet, so I'll call it x and x. And that's what the question's asking for, is x, the length of qy. So this time, the perimeter is going to be 15 plus 15 plus 17 plus 17 plus x. And the perimeter is 88. So this is going to be 64 plus 2x. So 24 is 2x,